Alright, so this is going to be a little look at special right triangles. I was asked to do a video about the unit circle, but I wanted to do this first because you really need to understand special triangles before you can understand the unit circle. So basically we can see there are two types of special triangles. There's a 30, 60, 90 triangle, and there's the 45, 45, 90 triangle. So 30, 60, 90 is called that because it has 30, 60, and 90 degree angles. And you have consistent ratios to your sides. Your shorter side, which is across from the 30 degree angle, would be 1a. Then your longer leg is a square root 3, and your hypotenuse is 2a. Your value of a will change because you might have a big 30, 60, 90 triangle, you might have a smaller one, but they all have those consistent ratios. And then likewise your 45, 45, 90 triangle will have your two congruent legs of 1a and 1a, and then the hypotenuse of a square root 2. And sometimes you might see a 45, 45, 90 triangle where the angles aren't even labeled, but you can always recognize it because it's an isosceles right triangle. These two legs are congruent to each other. So we're just going to look at a couple examples here. So it says finish labeling. So if we know this is a 30, 60, 90 degree triangle, then we can just figure, if we look at what our ratios should be, so across from the 30 degree angle is the 1a. So down here across from the 30 degree angle, this would be our 1a side. Our longer leg would be a square root 3, and our hypotenuse is 2a. So if we know that 2a is equal to 8, then that tells us that a is equal to 8 divided by 2, which is 4. And then if we know what a is, then we know all of our other sides. So 1a, if a is 4, 1 times 4 is 4. So we got this side labeled. And then if a is 4, then a root 3 would be 4 root 3. And we've got this side labeled. Then I want to do a 45, 45, 90 like that. So this one also says finish labeling. So our two legs should be 1a and 1a. And then our hypotenuse is a square root 2. So if we set this equal to a square root 2, we can cancel out the square root 2's and we just figure that a is equal to 7. So if we put that back into our other sides, we can easily do 1 times 7 is 7, and then both of these are equal to 7. So those are kind of some simple examples. Then I want to look at what happens when your hypotenuse is 1. I made both of these the hypotenuse 1 because that's a situation that we see in the unit circle. So these are going to give you some numbers if you've seen the unit circle before. You'll see some numbers that are perhaps a little familiar. And if you haven't seen the unit circle before, it's still good practice. So anyway, we got our side ratios because this is across from the 30 degrees. The longer leg is a square root 3, hypotenuse is 2a. Then if 2a is equal to 1, as we can see, then we would have to divide by 2. And we find here that a is equal to 1/2. So then we can use that to find our missing side. So this 1a, 1 times 1/2, this side would be 1/2, 1 over 2. And then this over here, a square root 3, if our a is 1/2, then 1/2 is going into this spot. So what we end up is 1/2 square root 3. But if we're multiplying, remember that's really square root 3 over 1. So we can just multiply straight across. 1 times square root 3, square root 3, and 2 times 1 is 2. So this side over here would be equal to square root 3 over 2. If you've seen the unit circle, these numbers should be familiar from seeing those on some of your sine and cosine values. Then the last one, when we look at our 45, 45, 90 triangle, let's see, we can label this up too. We got 1a, our hypotenuse is a root 2. We're given that it's equal to 1. So if we want to solve that out to find what a is, we would divide by the square root of 2. We would find a is equal to 1 over the square root of 2. Now, we probably want to rationalize that denominator though. So we can multiply by square root 2 on top and on bottom. And you end up with square root 2 over 2. That's your a value. And then for your legs, it's just 1 times that, so it's that same number. So these values are both square root 2 over 2. Again, these are numbers that will be familiar to anyone who has seen the unit circle.